Okay, you see, good morning, all of you. In Unit 5, we are discussing about these transmission lines. Is it over? Up to this. Okay, na? Ragashri?
ఇన్ఫినిటీ లైన్ స్టార్ట్ చేశారు సార్.
Okay, this is okay,
ఎస్
na?
ఎస్ ఎస్ సార్.
J not Javed. Okay, na?
ఎస్ సార్.
Now, you see the transmission line, the next one, the infinite line. You see, the infinite line means the length of the line is infinity. Now it is a transmission line. You see here towards the infinity, and the voltage at sending end, it is a sending end voltage. Yes, IS it is a sending end current, and whatever the impedance offered, this impedance is a characteristic impedance. So, what is the problem with infinite line? Whenever we are supplying the voltage continuously from sending end, because of the length of the line is infinity, there is no any wave received at the receiving end. So whatever the supplied voltage, that is totally absorbed by this line. G8 Praveen Kumar. Okay, na?
ఎస్ సార్.
Okay. Now this sending end voltage after 10 minutes class lock చేస్తాం అంతే కదా అది పెట్టమా పోస్ట్ చేయది 9:45 9:10 కి క్లాస్ లాక్ చేస్తాం.
ఓకే సార్.
Now the electric waves, whatever they are transmitting from the transmitting end, the total waves are the total wave is absorbed by this
Sir, I
line.
can't understand, sir.
Everma? I9. Now, whatever it is, we are transmitting this voltage, sending end voltage. This voltage is totally absorbed by this line. There is no any wave is received at the receiving. That is the problem with the infinite line. So, you see here, as the line has infinite length, no waves will ever reach at the receiving end, and there is no possibility of reflection at the receiving end. One more thing is, whenever there is so there is no any wave received at the receiving end. So there is no any reflection problem because no wave is received at the receiving end. Reflection ki chance alone. Another thing is, you see the reflected waves are option. The characteristic impedance, you remember this one. The characteristic impedance Z naught is decide how much voltage is, how much current is flowing through the line. So these are the two important properties of the infinite line. Next, coming for the short line. The meaning of short line, it is not a short circuited line. It is some out of the infinite line. We are going to consider a practical line with some finite line. You see, a short line means it is a practical line of a finite line. The short word indicates that here it is information related to the actual length of the line. It's small length of the line. So that is the meaning of a short line. Now you see, it is the infinite line. The length of the line is, it is an infinite line. Now, this infinite line, we are separating some part from this, we are separating some part. So you see here, this AB is now a short line. Now remaining this line, entirely it is a infinite line. So out of infinite line, we are cutting some length of the line, that is a short line. From A to B, a short line. Now this, you see 1, 2, and the length of the short line is AB. Remaining length is infinite line. You see towards the infinity, and whatever the impedance offered by this infinite line is a Z naught characteristic impedance. Now you see, whenever this line is, suppose this finite line is terminated here. The finite line is terminated here. Now what is the impedance offered by this infinite length? What is the impedance offered by this infinite line? It is a Z naught. Now the same thing is here terminated. So the finite length is terminated with Z naught. The same Z naught is offered input impedance for infinite line. So that is remember. This point is remember. So whatever the infinite line, still it is an infinite line. It offers the impedance. Input impedance is a Z naught. This Z naught is terminated with this finite line because the output of this one is a input for this infinite line. Output of this finite length is input for the infinite line. So whatever the impedance is terminated at the short line, that is offered by input impedance of this infinite line. Now you see here, what are the finite line? This finite line is terminated with Z naught. So this output impedance of this line, output impedance of this line is same as the input impedance of this infinite line. So whatever the impedance is offered, it is a Z naught that is terminated here. So we are considering the short section. This line is terminated with Z naught. So thus we can conclude that the finite line which is terminated in its characteristic impedance, you see this is important. A finite line which is terminated in its characteristic impedance behaves as an infinite line. This point is very important. The finite line is terminated in its characteristic impedance behaves as an infinite line. So what is the behavior of infinite line? Already we have seen. What is the behavior of infinite line? What is the behavior of infinite line? There is no any reflected wave from the receiving end to the sending end. So here, whenever this short line is behaving like a infinite line, this means that there is no any reflection, and the input impedance also. You see here, what is the infinite line property here? The input impedance is Z naught, and there is no any reflection from receiving end to sending end. These are the properties of infinite line. So the same properties of infinite line are applicable for short line whenever the line is terminated with Z naught. So we can say that the line, the short line is terminated with Z naught. Now there is no any reflection take place from this B to A. At the same time, whatever the impedance offered by this input side, that is characteristic impedance Z naught. So these two remember, input impedance of this finite line is Z naught, and there is no any reflection from receiving end to sending end. So we are concluding that this short line, whenever it is terminated with characteristic impedance, it is behaving like a infinite line. Now you see, a determination of characteristic impedance Z naught is a characteristic impedance of a finite line terminated in Z naught. It is important. Determination of Z naught for a finite line. It is a finite line. It is terminated with Z naught. You see here, this finite line, it is terminated with Z naught. It is behaving like a infinite line. So what are the two properties of infinite line? There is no any reflected wave from receiving end to sending end, and whatever the impedance is offered by this infinite line is a Z naught. So you see, this Zn is equal to, Zn means input impedance of this finite line. So Zn is equal to Z naught. This line is terminated with Z naught. Now what is this finite line? We are going to write this is represented with a symmetrical network, a T equivalent. It is like a T shape. It is a equivalent to T section. Every finite line we are going to write like this equivalent T section for analyzing this line. Now this for series, it is going to be represented Z1 by 2. It is one Z1 by 2. It is another Z1 by 2. And there is in shunt, there is a Z2. So this Z1, there is a combination of, already we know what are the series parameters. We have a series parameters, resistance and inductance. So R plus J omega L here, and coming for Z, now 1 by G plus J omega C, or Y is equal to G plus J omega C. Here there is a conductance and capacitance will occur. Now here there is a series resistance and inductance. So each finite line is going to be right an equivalent T section. In this T section, there is a Z1 by 2, Z1 by 2, and Z2. You remember this? It is a Z1 by 2, Z1 by 2, it is a Z2. Okay? It is equivalent. Now, in this T section, it is, remember, this is a equivalent. This, for analyzing this finite line, we are going to assuming like a T equivalent sections. So, there is a resistance and inductance combination, resistance and inductance combination, and capacitance and conductance combination here. Now here you see the line is terminated with Z0 and the it is behaves like a infinite line. So whatever the impedance offered by this finite line, that is also Z0. Now we see the calculation of this impedance. Now these two are in Europe respond on Bhagasri. Bhagasri. Bhagasri
Sir.
are there. These two are in series or parallel. These two are in series or parallel?
Series, sir.
Series. So you can add. You see here Z1 by 2 plus Z0. These two are in series. And then this resistance is parallel with
Z1 by 2 and
this
Z0.
one. Z2. This Z1 by 2 plus Z0 is parallel with this Z2. You see here.
Z2.
Z2. And then it is series with Z1 by 2.
Z1 by
So
2.
Z1 by 2 plus Z0 is series and this term is parallel with Z2 and this is series with Z1 by 2. So it is the input impedance offered by this finite line. So it is a parallel circuit. You know, two resistors are in parallel, R1 R2 by R1 plus R2. It is a Z2 Z1 by 2 plus Z0 divided by Z2 plus Z1 by 2 plus Z0. It is equal to Z1 by 2. It is the input impedance offered by this line. Next, you see here, this Zn input impedance is equal to characteristic impedance Z0. So you substitute here Zn is equal to Z0 here, and then you simplify this one. You take LCM here. Now Z1 into this Z2 plus Z1 by 2 plus Z0 into Z2 into Z1 by 2 plus Z0 into 2. So this 2 into Z2 plus Z1 by 2 plus Z0, you write this from denominator to numerator. You will get 2 into Z2 plus Z1 by 2 plus Z0 into this Z0. And then you multiply this one. 2 Z0 Z2 next plus 2 gets cancelled, will get Z0 Z1 and then 2 Z0 square is equal to Z1 Z2 Z1 square by 2 Z1 Z0 2 gets cancelled Z1 Z2 plus 2 into Z0 Z2. So it is the after multiplication. Now is there any common things you see here? You see here Z0 Z1 Z0 Z1 gets cancelled, and then you see here 2 Z0 Z2 2 Z0 Z2 gets cancelled. So here 2 into Z0 square. The remaining thing we have, this is a Z1 Z2. Here there is a Z1 Z2 2 Z1 Z2 Z1 square by 2. Next Z0 square is equal to, here if it is a multiplied, if we take it is in this side, right side. So Z1 Z2 already there is Z1 square by 2, you will get a Z1 square by 4. So Z0 square is equal to Z1 square by 4 plus Z1 Z2. So finally characteristic impedance Z0 is equal to root of Z1 square by 4 plus Z1 Z2. You see here characteristic impedance Z0 is equal to root of Z1 square by 4 plus Z1 Z2. Okay now? Now it is about a characteristic impedance of a finite line. That line is terminated with Z0. That if you remember that point, whenever the line is terminated with a Z0, it is behaving like a infinite line. Whatever the remaining all calculations are, we are going to get easily. Whenever it is behaving like an infinite line, the impedance offered by this finite line is a Z naught. So Zn is equal to Z naught. This finite line we are going to write like a T equivalent section, that is Z1 by 2, Z1 by 2, Z2. And we are calculating the input impedance offered by this line. And finally, you substitute Zn is equal to Z naught. So we will get this characteristic impedance Z naught in terms of Z1 and Z. Okay, Z1 is related to series, Z2 is related to shunt. Okay, we will see that. Next, suppose the line is open. You see, in the open circuit, whatever the finite line, it is a open. So open means, what does it mean? What does it mean? There is no any current passing through this one. Whenever it is a open, what is the Zn? Previously, it is a Z naught. We have written Zn is equal to Z naught. Now, what is here? It is a open. So Zn is equal to ZOC, open circuit. So you see here, the this finite line is going to be represented into T equivalent circuit. So Zn or ZOC, open circuited at this end. Now, is there any current? Is there any current, Bhagishree? Hello?
No, sir.
There is no any current. So what is the ZOC now? Open circuited impedance. ZOC. These two are in now. These two are in now.
Parallel.
Parallel. ఇక్కడ కరెంట్ లేదు.
Series, sir.
Series.
Z1 by 2 Z.
Z1 by 2 plus Z2. So you see this ZOC, ZOC is equal to Z1 by 2 plus Z2. Now coming for this, whenever the line is short circuited, whenever the line is short circuited, what is the impedance offered Zn? ZS. You remember, whenever the line is terminated with Z naught, Zn is equal to Z naught. Whenever the line is open circuited, Zn is equal to ZOC. Whenever the line is short circuited, Zn is equal to ZSC. Now this line is short circuited. Now you see here, whenever it is short circuited, what is these two? These two are in. These two are in. Obviously,
Parallel.
these two are in parallel.
Parallel,
And then it is a series. Now you see ZSC,
series.
short circuited impedance is equal to Z1 by 2 plus Z1 by 2 parallel with Z2 plus Z1 by 2. Now it is equal to Z1 by 2 plus Z1 by 2 into Z2 by Z1 by 2 plus